Thank you very much for coming here tonight. My name is Brian Hoskins. I'm Director of the Grantham Institute here at Imperial College, and it is a great pleasure to see you, but also to see our speaker here tonight. But introducing him then is going to be James Kierstead. James, over to you.
Thank you, Brian. Yeah, so my name is James Kierstead. I'm a lecturer here in the Department of Civil Engineering. It's a real pleasure to welcome Mark here as our speaker tonight. Mark is a very well-known author, journalist, environmental activist. He's worked on a number of issues, including climate change, nuclear power, genetic engineering. And you may know of him from some of his earlier books on climate change. So there was High Tide and 6 Degrees, which won the Royal Society Prize for Best Popular Science Book in 2008. And it was quite interesting, I think, in looking at how the incremental impacts of climate change as temperatures ramped upward. In the talk tonight, though, Mark's starting to look a bit more widely at the other factors that affect the sustainability of life on Earth. So we're looking at the 9 planetary boundaries that must be respected if we're meant to maintain life and civilization as we know it. I had a chance to read it when it came out early in the review process, I guess, and it was really entertaining. The science, I think, is an excellent summary of all the relevant issues for these planetary boundaries. And there's some really good stuff in there about the politics of the environmental movement, how they respond to each of these issues. So I think we're in for a real treat tonight, and I'd like you to join me in welcoming our speaker, Mark Linus.
Thank you. Am I on? Thank you, I'm on. Thank you, sound people, you're brilliant. And thank you all for being here tonight. Thanks to the Grantham Institute for hosting this. Thanks, James, for that introduction. I'd like to start by putting everything that we discuss in the very longest term possible context, and that's the context of an entire geological timeline, right? So, starting off with the original evolution of life on Earth 3.7 billion years ago. We still don't know how that happened, by the way. Going through the Cretaceous, Carboniferous, into this tiny little bit here called the Cenozoic, and this very, very tiny little bit here called the Pleistocene, which is the last ice ages, and the Quaternary, and the Holocene, which is us, just here. So we're very insignificant in terms of our longevity on here on this planet, but I think we're very significant when it comes to our impact. And that's really what I'm going to focus on here tonight. But let's put this in a bit more context first. Fully modern humans first evolved about 1.5 million years ago, but I would say fully modern in the sense of civilizational humans, so after having developed settled agriculture, urban centers, and a complex civilization, that begins in this period here of very stable temperatures known as the Holocene. And I don't think this is a coincidence. I'm sure that there is a correlation between the fact that when you have this up and down and up and down and up and down during the last ice age, this real roller coaster ride of global temperatures, which is preserved in the ice cores and the oxygen isotope record, when that gives way to the Holocene, you have this warming up and this very, very long 10,000 year period of stable temperatures. That's when humans emerge into their fully civilized, culturally evolved species that we see here today. And that has transformed the planet in a way which is really unprecedented in the entire geological timeline. So much so that the geological community is going back to the drawing board and discussing amongst itself at the moment whether to declare the Holocene over and declare the Anthropocene as the new geological era. Because this is an era where us humans have changed the temperature of the planet, the chemistry of the oceans, the equilibrium of the atmosphere, we've changed the composition of the land surface, all of the species that are here with us, and we've really transformed the way that the planet operates in terms of its chemical and biological cycles. And I think this gives us a responsibility to be planetary managers, because there is danger, of course. This has been an enormous benefit, a huge boon to humanity. We've got 7 billion people increasingly adequately well fed. But we can only do this by appropriating something between a quarter and a third of the entire photosynthetic production of the planet, right? So between a quarter and a third of everything that's produced in the season on land goes to sustaining this one single species. And that, of course, shifts other species to the margins, and that's a real problem. Now, James mentioned about planetary boundaries, and the conceptual illustration is here. The idea is that there are safe operating zones in terms of how the Earth's operated during the Holocene in its natural state. So a state of a relatively stable climate, relative stability in terms of the other chemical and biological cycles. And this is illustrated here. So you've got your safe space, but if you push past the threshold, and remember you don't know where the threshold is, there's this zone of uncertainty here, but you can quantify it to some extent on this line. Once you push past the threshold, you're into an entirely new state down here. And a bit like a ball going round and down the hill, it's going to be difficult to push it back uphill. So the point is, if you cross over tipping points in terms of what you affect biodiversity, how you affect climate, then potentially you're into a whole new state of disequilibrium, where the planet is not stable anymore and where it's not able to sustain humanity in the manner to which we've become accustomed. So let's knock quickly through these 9 planetary boundaries. I'm sorry 9 isn't a very round number. I think they looked for 10, but they couldn't find another one, so 9 it is. Now, what's really interesting about this is that the scientists led by Johan Rockström, Professor Johan Rockström of the Stockholm Resilience Center, have actually tried to put numbers on as many of these boundaries as they can. So they've tried to quantify scientifically what the limits are to our interference with the Earth system. And I put biodiversity boundary. They don't assign them any order of importance, but I put biodiversity first because I've spent 10 years working in climate, and I actually think biodiversity is arguably more important. The reason being that we are now in the throes of the world's worst mass extinction since the end of the dinosaurs 65 million years ago. If I remember rightly, a quarter of mammals, a third of amphibians, a sixth of birds, a quarter of warm water corals, and a quarter of freshwater fish are on the endangered species list now, threatened with extinction. And in fact, and the statistic which shocked me most of all when I was writing the book was that there was a third less, this isn't about species, this is about the abundance of animals. There's a third less wild animals in total on the planet than there were just 40 years ago. So even while species persist, the abundance of them has declined dramatically. And that's, of course, because humans have outcompeted, we've eaten, we've poisoned, we've done everything we can to support ourselves on this planet to the exclusion of other species. Now, the boundary that's proposed here is that we should keep the extinction rate close to the background level. Obviously, species extinction goes on through geological time. Species disappear naturally all the time. That's how evolution takes place. But we should keep the extinction rate below 10 species per million per year. We're currently probably 2 orders of magnitude above that. So we're losing between 100 and 1,000 species per million per year. So we're way over that boundary. So if you think of it in terms of a safe operating space, we're now into the danger zone, well into the danger zone in terms of this biodiversity boundary. So number 2 then is climate change. I like this little graph. This is how skeptics see global warming. There's several periods of cooling all interspersed upon each other. You might hear people say that global warming stopped in 1998. If we look at it again, you can actually see that they're quite right. Global warming did stop in 1998. There you are. Look, there's no warming at all. So that tells you, doesn't it, that global warming isn't happening. Of course, that's kind of silly, and we all think it's sort of amusing. I don't suppose there's that many of you here who subscribe to that viewpoint, particularly given that it would be incredibly difficult to explain physically how you can have an increase in carbon dioxide, which is certain, right? There's no argument about that. We know that carbon dioxide is increasing. We know for sure that it's due to human activities, fossil fuel burning primarily. And we know for sure that carbon dioxide is a greenhouse gas. It has a radiative forcing effect on the climate. It's opaque to infrared radiation, so you would expect the planet to be warming up. So if the planet were cooling, that would have a devil of a time to explain that. You know, what would be happening? You know, the first law of thermodynamics is that energy is conserved. It has to go somewhere. Energy can't disappear. It can't be destroyed. So, and we also know from satellites that the Earth is in energy imbalance. So the Earth is gaining more energy than it's losing to space. And that, of course, is the process of global warming viewed from outside. Now, in terms of the planetary boundary proposal here, the planetary boundary scientists are proposing something really quite shocking, which is that we are well over the permissible level of carbon dioxide in the atmosphere already. So we're not talking about extra emissions allowable in future decades. We're talking about having to retreat back from this boundary. We crossed that 350 parts per million level in 1988, and we're now at 391 parts per million, as I'm sure most of you know. So there isn't any space left in the atmosphere to emit more carbon. We have to somehow design a carbon negative economy past 2050, going on to the end of this century. So this is the huge challenge that we have presented before us with climate change. If we want to retain the long-term integrity of the ice sheets, we know this from paleoclimate, there weren't any ice sheets when carbon dioxide levels were high before in the geological past. So the estimation is that 350 is the level where to keep the sea levels within relatively tolerable bounds and to keep the ice sheets there, which of course is very important for the albedo of the planet. Once you get rid of the Arctic ice sheet, once you get rid of the Antarctic eventually, you'd have a much less reflective planet, and you have a much warmer planet permanently as a result. The third boundary is a much more interesting one, actually, and border climate change. And it's one which we've affected more than the carbon cycle. And these two gentlemen are responsible for it. And this is the point, actually, where this is a very august audience. I'm sure you will all know exactly who these two people are. Because if I tell you the story, back in 1900, there was a whole movement of scientists, mostly based here in London, who were, the senior, most eminent scientists of their day, who were extremely concerned that humanity would not be able to feed itself, due to the fact that the naturally occurring fertilizer in the deserts of Chile were potentially running out. And if you don't have fertilizer, of course, you don't have crops. So where could we get the fertilizer to feed humanity? Now, rather than saying that we had to somehow, I don't know, have a rationing system, or people had to have fewer and fewer children, or whatever, any kind of malfusion stuff, they said that this problem would be solved in the laboratory. And indeed it was, in 1912, by this chap on the left, who is, of course, Fritz Haber, and was fully commercialized and developed by this chap on the right, who is, of course, no? Carl Bosch, yes, Carl Bosch, through the Haber-Bosch process. They both got Nobel Prizes as a result. And what they figured out how to do was to take unreactive N2 nitrogen in the atmosphere, which is 72% of the air, it's everything we breathe, add hydrogen to it essentially and come out with ammonia. Now this is something in nature that doesn't happen very often. It only happens when things are burning, it happens in the root nodules of leguminous plants, and I think it happens when lightning strikes and forms nitrogen oxides in the air around it. So nitrogen is actually in nature a very scarce, very limiting resource. It's the limiting nutrient in most ecosystems. So us humans come along, and we're only the second species after rhizobium bacteria that can fix nitrogen, right? We've evolved this property. It's quite an amazing thing that we've learned how to do. And that enables us to transform global agriculture. Remember, back in 1900, before the Haber-Bosch process had been invented, really we would not have been able to feed most of the world's population. Certainly we wouldn't be able to feed anything like the population we have today. So that's a good thing, but it does have drawbacks, of course. And there's a boundary attached to this precisely for that reason, that we've doubled the terrestrial nitrogen cycle, right? So we've multiplied by 2 the amount of nitrogen which is circling through all of the Earth's terrestrial ecosystems. This is washing off into the watercourses. It's causing eutrophication, which is a major biodiversity problem in freshwater ecosystems. And it's causing dead zones, like the several tens of thousands square kilometer dead zone in the Gulf of Mexico, where all the fertilizers wash out of the US Corn Belt and into the shallow oceans there, cause algal blooms, and that depletes the oxygen from the water column and kills all the fish and kills everything else. Nothing can live there because there's no oxygen in the whole of the water. So what's the proposed boundary? 35 million tons per year of nitrogen should be the limit to what we fix in order to protect the world's oceans and rivers from nitrogen pollution. We're currently using 121 million. Now, I think the carbon cycle, I think fixing climate change is a doddle compared to this, because we've got to, this is something which you can't replace biologically, right? Half of all of our bodies are synthetic in the sense that they are created from proteins which we've eaten from synthetic nitrogen fixed in an ammonia plant. So how can we go about doing this? I think this is going to be a huge challenge to use nitrogen much more efficiently in world farming. I'll have some proposals about how we do that later. So we're over that boundary too. Number 4 is perhaps a less familiar one. And this is about the transformation of the world's land surface by human activity. There's your geography lesson textbooks, zones. These are the ecological zones. There's the Amazon, there's the deserts, the red areas of the Mediterranean ecosystem, there's the boreal forest and the tundra. And we're in a much more fragmented situation where the biomes, the traditional ecological zones, have turned into anthromes, anthropogenic biomes. Because we've fragmented all of these ecosystems for farming and for everything else to sustain ourselves. Now that's great news for humanity, of course, but it does put a lot of pressure on ecosystems, and it does mean that there's a lot less space there for biodiversity. And the proposed boundary is that we should keep the amount of the land surface that we devote exclusively to crops, right? So we've transformed almost all of the land surface in one way or another, except for some high mountains and a bit of tundra and stuff. But in terms of only producing crops, it should be 15%. We're now at about 12. So, we're quite close to that. And this says a lot in terms of how we feed humanity going forward with an increasing population and an increasingly wealthy population. We've got 9.5 billion people coming down the line. We've got to feed all of them, and we've got to do so on pretty much the same amount of land that we've got now if we're to hold to this. And remember, we've got problems with fertilizer as well. And we've got problems with water. This is another scarce resource, in fact, more of a scarce resource than many others, increasingly in a world where climate change is affecting the persistence of snow and ice on high mountain ranges, and the hydrology of the rivers. So one of the ways that the snowpack of the Western Sierras in America is captured, of course, is here behind the Hoover Dam on the Colorado River. So this is the way of getting rid of the whole seasonality problem of snowfall only being available in the spring and the early summer, and then having droughts later on in the year. The problem is there isn't enough water in total to sustain this. So the Colorado River doesn't reach the sea now for most of the year, and many of the other major rivers that sustain human production are similarly affected. So this is a real problem. I think it's problematic, however, to have a proposed boundary in terms of a globally quantified number, because of course each river is different. It depends on the climate of each particular place. All the same, they're suggesting 4,000 cubic kilometers. We're at about 2.5 now, so we've got a little bit of space there, but it depends on how we use different rivers. So there's a limit to what we can have in terms of hydroelectricity. Remember, we're trying to solve climate change here. We can't go around damming the rivers because freshwater ecosystems are some of the most endangered on the planet. So this is a real challenge in terms of how these different boundaries interact. And not all the boundaries are quantified. The amount of aerosol, particulate, pollution that humans are producing is quite extraordinary. You can see this is China here, almost entirely underneath a layer of smog, which is why if you're in Beijing, I don't know if any of you from China or from, they actually have blue sky days. They don't have polluted days, they have blue sky days, the rare days when you can actually see the sky and you can see the sun. And that's, of course, because of industrial pollution largely. This is up in the Himalayas in Nepal, where you've got this Asian brown cloud sweeping north out of India. That's mostly biomass burning. So that's ordinary people, peasant farmers, burning straw, dung, whatever, to feed their families, often in highly polluted indoor cooking situations. But aerosols have, as far as the climatologists can determine, a largely cooling effect. So all of these particles which make up this massive great cloud here are reflective, by and large. And so they're actually shielding us from a certain amount of global warming. And because tens of thousands of people die every year from air pollution, this is a problem which will be being addressed. But the problem is that if we do that, we accelerate global warming. So I can tell you, as far as the models say, when the Chinese clean up their act, we're going to see another 0.5 degree of global warming. So a third as much as we've seen already for the entire 20th century. Through that simple act. So one of the proposals, which I think is interesting, I don't think it's an open and shut case by any stretch of the imagination, is to take all of this crap out of the troposphere, where we have to breathe it and put it up into the stratosphere, where you don't have to breathe it. So we can take sulfur dioxide particles, spread them through the stratosphere. This is called geoengineering, a very controversial topic. If we can do that, we don't have to fire them up there with sulfur guns or whatever. It's basically doing what volcanoes do naturally every 10 or 20 years. So we know for certain that it has a cooling effect. What we don't know is what the global impact is going to be on the hydrological cycle and so on and so forth. So we only have one planet. It's a better way to experiment on is through computer models, I think, at the moment. So this is one to have in the back pocket in case of extreme need and urgency. Remember, aerosols are very complicated and there's no figure put on that. Now we know, and environmentalists have campaigned for decades on this toxics issue, that there are pesticides, there are lots of novel chemicals which humans have created, which are not synthesized by bacteria. They can't be biodegraded because they are new. Some of these accumulate in the food chain up in the Arctic, some of them having impacts on amphibians and so on. Difficult to say what the impacts are. It's very controversial on different species, but certainly this is having an effect on biodiversity. But again, we can't put a figure on it. So this is one to bear in mind for the future. Now, number 8 also involves a chemical equation, which is actually extremely simple. If you dissolve carbon dioxide in an aqueous solution, i.e. in the oceans, you get carbonic acid, which turns into hydrogen ions and various bicarbonates and this and that. Somebody else who's a chemist can explain it. But basically, you're making the oceans more acidic. And this is the problem if you're a coral reef. And we're looking at a situation where most tropical coral reefs in the latter half of the century will not be able to survive in acidic oceans. So this is a huge evil twin CO2 problem, they call it. We've got to, even if we tackled climate change through geoengineering or something, we'd still have to deal with the CO2 problem making the oceans more acidic. So this is a real challenge, and the only way I can think of to deal with it is to remove CO2 emissions and to draw down somehow some of the accumulated carbon dioxide, which is in the atmosphere. And there's a proposed boundary here which is quantified in terms of aragonite, which is a form of calcium carbonate which corals and other oceanic organisms use. We are heading towards that boundary quite quickly. So we've probably got 3 or 4 decades left. And number 9 here, another quiz for you here. Who's that chap? Anyone? James Lovelock. No, James Lovelock's even older. No, it's he's the guy who invented CFCs. Yeah. And he also invented tetraethyl lead, so lead in petrol. So, in fact, it's been said by a historian that he had more influence on the Earth's biosphere than any single organism that ever existed before him. Because he almost destroyed the ozone layer. He's called Thomas Midgley, by the way. He used to carry a periodic table in his pocket. This is an interesting little story. And when he was looking for a refrigerant to replace some of the ammonia and all the nasties that they used to use in the very early designs of fridges, he had a toss-up between chlorine and bromine, and he chose chlorine and developed CFCs, chlorofluorocarbons out. And had he chosen bromine, this big hole here would have extended over the entire atmosphere by about 1975. So well before we had any chance of determining that there was a possible problem with atmospheric chemistry, because all the Nobel Prizes for discovering that came in the early 80s. So anyway, you win some, you lose some, and we won that one. The boundary, as it's quantified here, we are now back on the right-hand side of, and we are, because we have reduced the emissions of CFCs right down to almost negligible levels in both developed and developing countries, and that's a huge success. So I end with this one because this is what's the opposite of cautionary tale? Everything's a cautionary tale. I don't even know what. Anyway, this is a way that humans have successfully managed the Earth system, not just in our interest, but in the interest of all of life on Earth by protecting the global ozone layer. Now, this is where things get more interesting. I'm going to talk a bit about the future and some of my thoughts and ideas about how we can address the interactions between these different boundaries. And I think we need to be very clear about what the central challenge is here. We're going to have a population by 2050, unless we get hit by an asteroid or a big flu outbreak or something, of 9.5 billion people. And I think it's desirable for all of them to be able to live at Western levels of consumption. And I don't know whether that's a controversial statement in and of itself, or whether everybody accepts that it's desirable for everyone, the whole world's population, to live at the same levels of affluence that we do. Are we all agreed that that's a desirable? Yeah? No? Okay, right. That gives me an excuse then to switch to a graph. The reason being that even if you don't think that affluence and GDP are necessarily the best things in the world, you probably do accept that child mortality, reducing child mortality as far as possible, is a good thing, right? Anyone want to see more babies die or more children die when they're younger? Normally one or two misanthropists put their hands up, but...
Fewer births.
All right, we can deal with fertility later, but we'll come to that, absolutely. But anyway, this is an interactive moving graph, courtesy of gapminder.org, and this has all of the incredible thing, really, has all of the data from all of the UN agencies offline and not even on the internet, so use this at home. On the x-axis here, we've got income per capita, right? So purchasing PPP adjusted. On this side, we've got child mortality. Each of these bubbles is a country. So in fact, and the date here, can you see the dates on this? This is 2009. We don't want it in 2009. We want to go right back to the beginning of the time. This is what the first data we have is for a little country somewhere in the north called Sweden. And in 1800, Sweden had an infant mortality rate of 380 per 1,000. So about a third of children, more than a third of children died before they could reach adulthood. Actually, before they could reach 5 years old, I think it says there. And a GDP of 1,000. So now let's play this forward in time. You'll see more countries appear on the screen as we get data, because of course only the Swedes were keeping records back in 1800. So all of these dots are different countries. You can see some of those. So these are European countries, which are the only ones we've got records for. And they're getting gradually richer, but not much is happening to child mortality until we get into the 20th century, and we've got much better advances in healthcare. That's India over there. This is the United States. Now watch the correlation evolve, and watch the countries all evolve downwards onto what is really quite a spectacular relationship, I think. And what's also really interesting about this is that, remember what was the Swedish infant mortality? 380, wasn't it? And now the worst, so the highest up here, the worst country in the world is Chad at 209. So even the most messed up, poverty-stricken country in the world now has a better infant mortality rate than even Sweden did, which was one of the richest countries in the world back in 1800. And look how linear straight this line is. And what I'm demonstrating to you here is the relationship between GDP, of course, and infant mortality, and I don't think that's deniable. So if we take it as a proxy, and if we assume that it's a good thing that children don't die before the age of 5, then let's look at how we can support people at that bottom right-hand corner, right? Where the infant mortality is... Yeah, go ahead.
Correlation and not causation.
Yeah, but you know, it's a fairly linear relationship. I mean, there's a whole bunch of other things which are welfare indicators, which we could talk about.
On that point, if we took Cuba, which has a pretty...
No, let's find Cuba. We can find Cuba. I can find individual countries down here, so we don't have to talk in... there we are. So let's see what happens. So Cuba's actually not as poor. I mean, I'm an anti-communist. I like to think that Cuba's really poor, but it's not too bad, actually. It's up to close to 10,000. But it's an outlier in the sense that it has a relatively low infant mortality rate for being a relatively poor country. And there's some countries actually which are outliers on the other side, like Equatorial Guinea, which is on income terms it's relatively well off, but it's extremely unequal. So most of the wealth goes to about 3 people, like the president and his family. So on average terms, it's wealthy, but in terms of how people live in Equatorial Guinea, it's not wealthy, and that's why it's an outlier in terms of this particular indicator. But let me get back to my point. We've got to support 9.5 billion people living at Western levels of consumption. I would contend you don't have to accept this within the planetary boundaries. So that's what I think our challenge is today. And I don't think we can do that by asking for some kind of voluntary austerity. I mean, maybe one or two of you are into austerity and you think that you can maybe, I don't know, give up on stuff. And I mean, actually, I was doing a talk, when was it, yesterday, the day before, in Sheffield, and there were, a couple of people were suggesting that we could kind of meet the Chinese halfway, right? And we could say, well, you can stop your development now, probably quite soon, because the Chinese are getting relatively wealthy. Something like, what is it, 300, 400 million people have been lifted out of poverty in China in the last 2 decades or something. I mean, that's a real miracle, and I think that's to be celebrated. But anyway, we've got to do this. I think this is our central task for the century to come. And here's some ideas about how we can do it. Now, urbanization is, I think, one of humanity's most inherently environmentally friendly traits. We like to live in extremely concentrated agglomerations of ourselves rather than spread out all over the countryside, which makes it far more efficient to provide services, to provide education. Gives us many more opportunities. The reason people move to the cities is because they have a lot more interaction with other people, they can set up businesses, they can get properly educated, they can live the kind of lifestyles that they want to live. You know, if you want to be, in many traditional societies, you can't be female and get a proper education, you can't marry who you like, and woe betide you if you want to have a civil partnership with somebody of the same sex. So cities have a lot of inherent benefits which cover a whole variety of different cultural things, which is why they appeal to people. And that's why there's so many new cities springing up all the time in terms of the numbers of people. And 2008, by the way, was an incredibly important year because that was the year of the urban transition, in the sense that more humans were in urban areas in 2008 than ever before. Now, the projections are, by the way, how many cities do you think there'll be of over 1 million people in India? Another question for you by 2030. 30? Anyone else? The answer is 68. China, obviously there's going to be a few more. 221. And in fact, there's a lot of Chinese cities out now which have 10 or 15 million people, which no one even knows the names of in this country. It's extraordinary, really, how rapidly the urbanization trend is developing. Now, somebody over there mentioned fertility, and there's a correlation I can show you on the graph between urbanization and fertility. We don't have as long a period of data here, so I can only go back to 1960 and forward to about 2005. So there you are. There's all the. It's not a. I don't think I could argue it's a absolute linear relationship, but there's one which becomes a bit clearer as you move forward through time. Countries tend to drop downwards, so the fertility, I think, declined somewhat after the urban transition. But again, you can see there's a very clear trend towards urbanization, which is coupled with a trend towards lower fertility. And that's a whole bunch of things which are probably easier to provide in cities, like family planning services. And there's a lot of evidence also that when people in subsistence farming, they want to have more children because they can help on the farm and all that, and they may lose some due to diseases. Whereas people in urban areas, their children are more likely to live, and they're actually an economic cost because you've got to educate them, you've got to pay to have them around, and they can't do anything helpful, as I know as a parent. So that's one, and I contend that urbanization and GDP growth defuse the population bomb. So goodbye, Paul Ehrlich, you were wrong. Now, turn off your cell phone or I'll throw it out the window. Sustainable intensification of agriculture. I've tried to select this as not an uncontentious way to promote genetic engineering, I'll be honest with you. But I mean that sort of, I'm kind of being silly, but this is absolutely central, right? The most important commodity that any of us consume is food, perhaps along with water. But if we are to deliver the Western lifestyles and the large amounts of consumption that people want, remember, poverty is defined as underconsumption, right? It isn't just defined in monetary terms. So having all of that food is essential if you're going to survive. So how are we going to provide that? Well, there are enormous challenges here for how we can improve on the success of the Green Revolution. Remember, the carrying capacity of the planet is not a fixed quantity. This is where the Malthusians and all these environmentalists who obsess about this, I think, get it dead wrong. If we all lived as hunter-gatherers, the planet could probably support about 100 million people in total, because it's an extremely inefficient way of supporting your society. You've got to go far and wide to find tubers, and you're not improving the productivity of the environment. If we all live without artificial fertilizers, the carrying capacity of the entire planet is probably about 1.5 billion people. the green revolution has increased the carrying capacity of the planet to 7 billion people. And we've got to find new technologies which increase the carrying capacity still further to 9.5 billion. And the population, remember, will level out at 10 or something billion. It's not going to keep on going up forever. So this is the problem. This population bomb thing is a problem which solves itself. And I do think that along with improved fertilizers, improved crop varieties are an absolutely essential tool. Now, not everyone agrees with me. And in fact, my younger self didn't agree with me. I used to be an anti-GM activist. And I used to go around cutting these crops down in the UK and other places. So I know from experience how wrong you can be about this particular issue. And no one's been wronger than this lady here, Vandana Shiva, who's the doyen of Western environmentalists. You often see her speaking to transition towns and things like that. Read what she's written. I'll let you read it, right? Can anyone spot the logical fallacy there? She's a physicist, by the way. The gradual spread of the sterility. How can sterility spread, right? How can having a sterile offspring, how can having a sterile parent result in sterile offspring which spread throughout the population? That's the most absurd and stupid thing that's ever been written in a book. And I can tell you it's in a book because I copied it from Google Books earlier on today. And this is, you know, this is, I mean, I'm not saying that the whole anti-GM movement is based on this, but I think there's a huge amount of urban myths and really kind of ridiculousness. And this is a sentence from a guy who, when I read this changed my life. The environmental movement's done more harm with its opposition to genetic engineering than any other thing we've been wrong about, and there's a few. We've starved people, hindered science, hurt the natural environment, and denied our own practitioners a crucial tool. And Stuart Brand, I think, he wrote a book called Whole Earth Discipline, which is an absolute must-read. And I think if you look at it and you look at the potential for GM technologies, and when I say this, people always shout out Monsanto. I hate Monsanto. It's an evil big corporation. Yeah, you know. But actually, some of the most interesting stuff's being done in the public sector. And some of the most interesting stuff being done in the public sector is for the benefit of subsistence farmers and to address some of these environmental challenges. I think what's really interesting is nitrogen-efficient crops, which can help us produce more from the same amount of land using less fertilizer. Drought-resistant crops, which can help us deal with climate change, changing weather patterns and leaving some areas without sufficient rainfall. Nutritionally enhanced crops, which can deliver, for example, vitamin A rice, which can give vitamin A to children who are lacking it and therefore are made blind. All of these things are opposed by the environmental movement, and that's why they've done harm, and that's wrong. Here's a solution which I don't think is necessarily so controversial, but I think it's potentially very important, and it's biochar. So if we take the agricultural waste, so all of the straw and the offcuts and all of the wood chips and all of this sort of stuff, billions of tons of this are produced every single year. If you feed it into a pyrolysis machine, you get out syngas, which is carbon monoxide and hydrogen, which is a very useful feedstock. You can burn it, you can generate electricity. Also, you can get out bio-oil, which you can use to, through the Fischer-Tropsch process, you can convert to any other form of hydrocarbon. So very interesting what you can get out of this. And what you get left at the end as a residue is this black stuff, basically charcoal, which is pure carbon, essentially, pure elemental carbon, a bit like diamonds, but not as valuable. Now, if you put them into agricultural soils, they, for some reason, improve the fertility of the soils, right? So you can improve the amount of nitrogen that crops can use, you can retain more water, you can retain soil fertility much better using large amounts of biochar, and best of all, it's sequesters as carbon, so it takes carbon out of the atmosphere and puts it into the land where it will stay for thousands of years. The mitigation potential, estimated by a paper I read in Nature a year or so ago, nearly 2 gigatons. They need 2 billion tons a year, so that's about a sixth, is it, of human emissions. Really, really interesting technology. Oh, and by the way, what can we do with that bio-oil? Well, we can make carbon-negative jet fuel out of it. So if we get enough of it, we can feed it into aeroplanes, they can fly around, and because you're putting this stuff underground, it's carbon-negative. Here's another really important one, not so much to us here in our rich, comfortable lifestyles, but the problem of indoor air pollution is one that environmentalists should have been campaigning about for the last 20 years, but haven't been. About 2 million people per year die because of the high levels of indoor pollution from cooking on open fires inside huts like this one. That's, I think, what is it? 3 people per minute. Most of those people are women and children because they're the ones who are in the home environment like that. And how do you solve that problem? Well, you can give them access to clean cook stoves. And as a result, they use a lot less forestry, so you get a lot less problem with deforestation, and you solve the pollution problem, which is killing so many people, and you address a major source of black carbon. These are the particulates, very small particulates, which are actually a warming part of the aerosols factor. And if you do that, you can save as many lives per hour as Chernobyl destroyed. So I think Greenpeace has got the wrong target here. And I say that because on my next slide, I'm going to talk a little bit about the mitigation potential of nuclear power. And I have to say, it was having written 2 books on climate change and convinced myself beyond any doubt that the climate was an almost impossibly serious challenge to humanity that really made me rethink the nuclear issue. I think according to the IPCC, something like 2 billion tons of carbon per year are avoided because of the current operation of nuclear power stations. That will have declined actually somewhat since Fukushima. That's a lot of carbon. And actually, if you look at what happens, since the 1970s, when the anti-nuclear movement really got going, almost all the power stations nuclear power stations that were proposed then were cancelled. And you know what happened instead? The world turned back to coal. And as a result, hundreds of coal-fired power stations have been built. There's even places where you can see the power stations that was built originally as nuclear was then converted into coal because of the process of so-called environmentalists. Now, all right, some of the older reactors are not ideal. Look what happened at Fukushima. If you have a loss of coolant accident, then you can have major releases of radiation. These releases of radiation are not a significant environmental problem. They don't affect biodiversity, but they are a health and safety issue for humans which needs to be taken very seriously. So let's design a reactor which performs better under stress. And this is one of them. So this is a sodium-cooled fast reactor. And what's interesting about fast reactors is that they can use 100% of the energy in the uranium, whereas light water reactors, like the reactors in Fukushima and all of the reactors which are running at the moment, only use 1% of the energy in the uranium. So all of the rest of it goes out as waste. So most of the nuclear waste in the world is actually spent fuel, highly radioactive. Feed it into this, and this was a headline from The Guardian only 2nd of February, so not very long ago. I don't know if you saw it, but the proposal is to build sodium-cooled reactors in this country. If you did so, just using the stockpiles of nuclear waste that we have lying around, we could generate 5 centuries worth of clean power with not a single ounce of carbon emitted in the process, right? And we can do that in a way that solves the nuclear waste problem. You've got all of this nuclear waste sitting there, which is not waste at all. Actually, it's a potentially very vital fuel for the future. Now, why are these safer? Because they can passively cool themselves. If you take away this coolant loop, the sodium is such a good conductor of heat that the heat can dissipate, and you don't get a meltdown, and you don't get any release of radiation. Another important thing is that sodium, this is liquid sodium, so it operates at about 200-300 Celsius. That means this doesn't need to be under any kind of pressure. So most reactors that operate at the moment are pressurized water reactors. They have to be under extreme pressure in order to keep water liquid in the reactor cool. If you have it under atmospheric pressure, then there's nothing to blow up. And all of this sodium to water loop, right? Sodium water reactor, if you don't want that, happens somewhere else in another building. But that's where you get your electricity generated. And by the way, the waste that you get out of the other side, because there's always waste at the end of a fission reaction, rather than remaining radioactive for tens of thousands of years, is radioactive for only about 300. I contend that I disagree with Stuart Brand about this, actually. I don't think GM is the thing environmentalists have got most wrong. I think opposing nuclear power is the things environmentalists have got most wrong. And that is a mistake. If we repeat this mistake, then the climate will pay the price. And here's some of the technologies that can deal with it. And I think this is the greenest single piece of engineering that I've seen for probably the last 10 years. Welcome to the fast reactor. Actually, no. How do we deal with the governance challenges that all of this presents us with? I've proposed that there's planetary boundaries. Remember, this isn't my idea. This comes from an august group of scientists some of whom are Nobel Prize winners and who know their stuff, right? But how can we actually get together as countries and deal with these problems? The climate change process is one that I'm most familiar with. Until about 2 weeks ago, I worked as advisor to the president of the Maldives, who's now been overthrown in a military coup, so I'm not doing that anymore. But for the time that I worked with him, for the previous 2 years, I attended a lot of these conferences and, tried to assist in one way or another in terms of how to find a way forward, which is the most positive. They call this the huddle that made history. I know all of these people personally. That's Pete Betts, that's Chris Huhn, who's our late Energy Secretary. That's Todd Stern. That's Masha Barney, she was the president of the COP. Oh, what's her name? She's from Colombia. Anyway, all of these people had not slept for 3 nights, I think, probably longer. So it's an incredibly time-consuming process to do this. But we've done it with some of these planetary boundary areas. So there's a Convention on Biodiversity, which has its own protocol, the Nagoya Protocol, which was agreed in Japan last year, which talks about protecting more of the land surface. That hasn't got the same kind of impetus behind it that climate change does, but it should do. We know about the climate change process. Toxics, there's a Stockholm Convention, which has banned about 12 of the worst chemicals, DDT, PCBs, things like that. And the EU has its own legislation on that too. And of course, I talked earlier on about the ozone layer. That was addressed by the Montreal Protocol back in 1987. And do you know which country was really pushing, which country single-handedly delivered us the Montreal Protocol and saved the ozone layer from extinction?
US.
Yes, the United States. Can you imagine that? It was the second country, the US Senate was the second legislature anywhere in the world to sign this treaty. Can you imagine that happening for climate change? You cannot.
Was that not because Dow Chemicals had the patent for non-CFC refrigeration?
No, actually, the Montreal Protocol was signed before the companies had delivered the substitutes. The companies had spent 15 years lobbying against it, and the politicians basically took a leap. And then the companies delivered the substitutes within about 2 years because there was suddenly a financial incentive to do so. But that's how flexible the capitalist system can be when you put the right pressure on it. And that's why my argument is that we need governance. There has to be democratically represented governments meeting globally in order to sort these boundaries out. It's not something you can do just technically. It's not something you can do just by getting scientists together. This has to have a democratic legitimacy, this kind of a process. Obviously, there's nothing for land use. There's nothing for ocean acidification. Nothing for nitrogen. Nothing. I mean, there's transboundary agreements on different rivers, for example, but nothing really on fresh water either. And certainly nothing on aerosols. I mentioned about that already. So our challenge is to run the planet as if we were gods. That's the God species idea. I don't really mean that. It's just a metaphor, so don't get too het up about it. But of course, this is from the Sistine Chapel, isn't it? So that's me, and that's Adam down there. And we've got to run the planet within the planetary boundaries, right? If you're lucky, I have one more video which might work. And I like to show this because, if I can get it to work on the screen, because it shows actually how amazing the planet still is, right? I talk about living in the Anthropocene, but it's the fact we can take this shot from the International Space Station. No other species designed international space stations and went up there. And look how we've lit up, how we've changed the color of the planet, we've transformed it in a way which is really unprecedented. And I think it's kind of beautiful as well. So I don't think that us humans are a pestilence or some kind of awful plague which needs to be addressed in terms of our impacts. Nor do I think that we are separate from nature. You can see we're very embedded in the planets, and all of our connective networks are embedded entirely in the planetary system. And that, I think, is a nice note to end on, because we do have this challenge. We've got to run the place. It's up to us. It's up to you. You're all voting citizens here. Please go and get on with it, because I've got to go home and look after my children. Thank you very much.
Right, I think there might be possibly a few questions after that. Erica, can you hear me? Okay. Erica, would you like to start off? Is this the only microphone too? So, okay.
Hello. Western consumption levels. I'm really not convinced. Why should they be the best possible thing to aspire to? I don't aspire to having plastic crap and fizzy brown sugar water and Facebook enhancing foreign holidays. I want something better than that.
You don't go on foreign holidays at all?
No.
And what's your income per year?
High, because I'm a PhD student.
Okay. Well, reduce it then. Live the way you want to. Live the way you want to live. What would be your income? What should be your? Oh, but you don't want everyone else to live like that.
I do, but I don't see the need for fizzy brown sugar water laced with phosphoric acid being a primary life-enhancing goal of mankind.
Coke, I like Coke. Coke's nice, especially Diet Coke. Anyway,
Well, I
the
suggested
point is about
drinking.
GDP, right? Your income per year, what is it?
What's our PhD stipend, Brian? You can tell us.
Come on,
16,000?
£5 a week or something.
No.
15,000.
In purchasing power parity, eh?
15,000?
Okay. So is that what you think of
I
the
think
rest
that's
of the world
extremely
should
high.
have?
I think that's very generous.
Could you lower it at all?
Well, no.
I mean, give away £5,000.
Yeah.
And what do you want? I mean, the fact is, I'm positing that as something I think is desirable. I don't think that anyone should have to live in poverty.
Neither do I.
Right. And how would you define poverty?
Not having enough. But
Enough,
I have,
but
I
enough
have
is
much more than enough.
Right. So everyone can live like you, fine. We still need to increase the productivity of the planet by about 2 or 3 times.
I think
But
because
how
you really have to be
much of the world's
first.
population lives on under $2 a day?
Quite a lot.
Yes.
Yeah.
So there's a huge amount of production we've got to do. We
But
can
there's
agree
a
on
huge
that.
amount of production that's already there that's not being shared out.
Yeah, well, I think this is a huge, huge issue. But the fact is that all of these countries want to deliver rapid development and rapid economic growth for their populations.
Yeah, I agree with that.
You-
I'm not against that. I think that's
Oh.
fantastic. What I'm against is the promotion of Western culture and Western civilization as being the best possible thing to aim for. And I think that's ridiculous.
Okay, well, fine, go over to Beijing and tell them that. Or
Well,
Delhi,
if,
or
we
anywhere.
if we stop living as if having fast cars was the only goal.
I'm sure they'll look to you and they'll see that you're a model to be. It's not flippant. I'm serious about it. There is this naive assumption, and I find this amongst environmentalists, and it really bugs me that if we're somehow a model for the rest of the world, and that the rest of the world aspires to live like us because we live like this. I don't think that's true at all. I think there's certain things that people want.
It's because of advertising.
Oh right, no, I totally disagree.
Right,
Totally
okay,
disagree.
okay, right, so let's pass it over, right.
Thank you very much. For the past 9 years, I've been working in Uganda. One of the projects I've been involved in is trying to get sustainable stoves adopted in rural areas. 80% of Uganda's population is rural, and the majority of those are very poor. And the Ministry of Energy in Kampala 10 years ago produced a report trying to encourage people to adopt sustainable stoves. And to date, it's been very, very slow. The diffusion of that technology, very, very slow. And what worries me is that the planetary boundaries are running away very quickly, and the adaptation rates are so much slower. And therefore, we're going to run up against the 10th boundary, which is a barrier between the scientists and the politicians and the people.
Okay, thank you.
Well, yeah, I mean, there's a multitude of reasons to be pessimistic. I'm not, though. I'm not pessimistic because, I mean, I don't pretend in any way that how many 5 or 6 different solutions I've presented or anything like a manifesto which is going to solve all these problems. These are just some ideas which I think are worth discussing. But it's up to us to figure out which technologies, which changes in governance make sense. I mean, one of the things which I think has been unfairly maligned is carbon offsetting. And a lot of the money that's been put into carbon offsetting goes to clean cook stoves. And all the Greens have been going around saying you mustn't offset because it's a complete con and blah, blah, blah. You know, and as a result, we could have been saving lives in countries like Uganda where these cook stoves are quite expensive, they cost money, but we could have saved lives and carbon had these things been promoted properly. Actually, Hillary Clinton is now behind this. Is the Global Alliance for Clean Cook Stove, which has got tens of millions going into it. So this is a problem which is being addressed. And when we get to the situation of everyone having high levels of GDP, then we'll be cooking on, hopefully on biogas or something, or electricity, even better.
Okay.
Hi, Mark.
Hello.
I think the last time I heard you speak in public was probably sometime in 2008. I don't know if you remember, it was at the RIDA.
No, I don't remember.
Do you remember? No. You played a film, I think you made with National Geographic. But anyway, I left the lecture really feeling chilled down my spine because I was absolutely clear that there's no way we could cap CO2 emissions at 450 ppm. But now 3.5 years on, I have to say I have a totally different impression of you as a presenter, as a scientist tonight. So this is not a technical question, or perhaps more personal and political. what happened in the last 3.5 years? Because this is not about
This is
science.
constructive.
I remember, I must say, not that I'm disappointed, just really, really different.
Are you disappointed?
No, I'm just thinking it's probably a completely different Mark Linus tonight from what I remember.
Yes, I've been captured and locked away by Bjorn Lomborg. No, it's I guess the process of writing this book changed me to a large degree, really. But I didn't want to write another book which said we've got all of these environmental problems and they're basically insoluble, so go away and weep somewhere in the corner, or come up with absurd proposals like reducing everyone's GDP or reducing the population or something like that. Do something which is, I wanted to come out with something which is pragmatic, right? Which is pragmatic but environmental at the same time, and I wanted to get away from the kinds of trenches that I think the environmental movement has got itself into, and which have made the whole environmental discourse so alienating to perhaps a majority of the population, certainly in Western countries. You have this whole phenomenon of climate change denialism. I think that's a reaction against the environmentalist discourse, really. It's not about the science, it's all about the scientists, really. So I wanted to try and have something which would have a bit more power to speak to people by making these problems seem tractable. And to do so in a way which is as honest as possible and as scientific as possible, but actually come to this with a sort of engineering perspective. And in 2008, I hadn't worked for a government. I've now spent 2 years working for a government of a developing country, and I couldn't honestly go to President Nasheed. That country is 70% dependent on long-haul flights. People who take trips to the Maldives keep the country going, because without that they'll be a lot poorer. And so you can't say to the president, right, we should start by reducing aviation, which is one of the things that environmentalists talk a lot about, which is shouldn't fly. All right, you should fly. We want to get as many people into Maldivian resorts as possible. So what do? You work on the problems which are tractable. So you say, right, we'll make the Maldives the world's first carbon neutral country. And that was an idea that the president was putting out in 2009, and we've gone some way towards doing that before the whole, it's thrown a span in the works, obviously, now being out of power. But we showed, I think, and we proved that it was economically feasible to do that, because this is a whole country that runs on diesel generators. So what do? You put in solar panels, you have battery technologies to back it up, and it ends up being an engineering challenge, not some great big ideological fight. And I thought, well, let's apply that, that kind of knowledge or that kind of approach to all the different planetary boundaries. But I don't make any major scientific claims for this. I don't claim that my thing on nuclear or cook stoves or anything else is based on science. I think the boundaries are based on science, and half of the book's about that. But in terms of my stuff, that comes from my own politics and my own subjective judgment.
Okay.
Hi, Mark. Thanks.
Where are you?
Thanks very much for your talk. I just wanted to kind of challenge you on the issue of companies like Monsanto putting lots of money into agriculture, and thus will be able to feed the 9.5 billion, 10 billion people. It's not necessarily like Western countries where we're going to be having to increase our yields. It's in places like Africa and Asia, and the staple crops there are maybe 80% grown by subsistence farmers, and it's not a place where these big companies are going to be making any money by investing in agriculture. So I was just wondering how we could encourage these big agricultural companies to, I guess, invest in stuff that isn't going to make them any money. What's the answer? Do we continue importing grain from the West, or what's the answer?
Well, it's quite interesting because India has this whole pharmaceuticals industry based on generic drugs, where they basically copy them from the patent. They basically breach the patents and they copy them. And the same actually happened with GM crops in India, where insect-resistant cotton, BT cotton, was imported illegally. So basically it was stolen off Monsanto. This is biopiracy in reverse. And all the farmers who were desperate to grow the stuff because they wouldn't have to use insecticides were then using it in their fields. And now, in fact, I think Monsanto's gone back into the game because they realised there was money to make. And that's the real challenge here. The problem with the anti-GM thing, though, is it's made the regulatory hurdles for getting a GM crop approved are so high that only the really big companies can do it. And this is the problem with the vitamin A rice, for example, which was developed 10 years ago. It's been stuck in the laboratory because of the regulatory hurdles, and the guy who's behind it's been writing ever more agonised and furious, papers in the scientific literature about this. and blaming the anti-biotech lobby for keeping, for making children blind as a result. I'm not, that's a pretty serious accusation to make, but it's a difficult one to deny because it costs something like $100, $200 million to get a GM technology off the shelf. That's why the public sector is really squeezed out. But there's a lot of stuff going on in the public sector in Africa and other places, and that's why, when people say I'm anti-GM, I say, well, all right, let's talk about stuff which isn't Monsanto, it isn't patented by anybody, but it's actually there for the benefit of subsistence farmers. It's got to increase yields, it's got to deliver something that they need and that they don't have now. Access to fertilizer. I mean, actually, we need more nitrogen in Africa. We need the green revolution to happen in Africa. It's a real problem is how to do that when the farmers don't have access to capital and don't have the inputs.
Biochar.
What's that?
Biochar.
Biochar.
Right, down here.
I've been interested in some of the stuff you said about like pragmatism and some of the harm that environmentalists or NGOs and you just now described it as seeing as an engineering problem. As an engineer, I've always been struck by that. That's something that seems to be largely about chemistry, in fact, like physical problems, is dominated by a lot of people who are in a hearts and minds battle. But then I suppose it seems that that's how people make decisions, purchasing decisions, political decisions and stuff, and that whether you saw any hope that the wider conversation would move to a more pragmatic approach, and like it's not ideal, but it seems like the best option, and just hating on stuff because it's new and you don't understand the problems and you get it somewhere.
I used to be anti-nuclear and anti-GM, and Stuart Brand wrote recently to me in an email that he thinks it takes 1.5 years for somebody to flip on this. And that's a good guess, actually, because that's about how long it took me from my very first thinking, oh, God, maybe we need to reconsider this a little bit towards being kind of full-out campaigner. And, but it might take a movement, it might take the environmental movement 1.5 decades. It's going to take 10 times as long because you've got that many people, and you've got all of these organizations with their whole established reputations on the line here. Look at Greenpeace, look at Friends of the Earth. Actually, I speak to a lot of the senior leadership in these organizations, and they're very smart, very intelligent, very passionate and caring people. And a lot of them know they're on the wrong side of the argument, on the wrong side of the science, on some of these areas. Now, Greenpeace does great work on deforestation, on overfishing, and a whole bunch of things. This isn't to say that green NGOs should be got rid of and somehow they're illegitimate. But when you do find yourself on the wrong side of an argument and you are hindering the, do we build a new generation of nuclear power stations in this country? It has a big impact on our carbon emissions going forward. There's so-called environmentalists campaigning against doing that, which means we'll emit more carbon. Now, that to me is not an environmental thing to do. So we're going to have this huge debate within and outside the environmental movement. And I don't even do this talk for environmentalists anymore. Any green groups, I say no, because people don't have enough open-mindedness to even engage. I'll talk to anybody, but they've got to be able to listen. And so it's difficult. I don't know. I mean, I've almost found myself between, because the political right doesn't want to hear any of the environmental stuff, and the political left, the green left, doesn't want to hear any of the solution stuff. And then you end up actually speaking to nobody. That's the danger. You've got to somehow
this audience isn't very
well, you're lovely, but I'm not sure whether any of you agree with me or not. But it's great you turned up. Thank you very much.
Thanks for your talk. Really interesting. I'm interested in the global governance aspects of this, and I think it would be good to have your views having kind of been insights in that process, because it seems to me as an outsider observer that we see a large-scale version of the prisoner's dilemma being enacted. In other words, it's very hard to get people to cooperate in a way that's mutually beneficial, and the more I kind of think about that, the more depressed I get, basically, because we have a whole range of solutions which are technically possible, maybe expensive, and that's a whole other issue. But getting people to actually move forward in a long-term sort of thinking way is really tricky. So I'd be interested in your points of view on that.
Yeah, but how did it work for the ozone layer and not work for the climate? That's a real question. And I actually think people talk a lot about behavioural change, and we should try and get people to, consume less carbon, whatever. But I reckon, and I can't prove this obviously, if we'd had to make people give up refrigeration in order to save the ozone layer, I bet there wouldn't be an ozone layer. And so it was technical substitutes which enabled that to be delivered, that outcome, and that problem to be solved. But before the technical substitutes came, the governments had to agree that that was desirable.
I thought, unlike you, that actually DuPont and ICI sort of had the
No,
knew where they were going.
there's a whole book about this which I've read, and it's really interesting because actually DuPont and ICI...
Don't believe every book you read.
Oh, this was a PhD anyway.
Oh, okay.
DuPont and ICI shut down their research programs in order not for no one to be able to say that there were substitutes, and in order not to influence the policy, because they were lobbying so actively against there being any regulations on it. So they didn't even want there to be any possibility of there being substitutes, and they would keep on doing what they'd always done. That's what vested interests do. They want to keep,
But they also have a bottom drawer, like Exxon would have a bottom drawer that is non-fossil fuel. So they have a bottom drawer to make sure they stay there.
As soon as the Montreal Protocol was signed, they restarted their research programs, and they had these things off the shelf and ready to market within about a year and a half.
Yeah, so they knew what they were doing.
Yeah, of course. But it's not as if there aren't any substitutes to the climate change problem. The problem is that the substitutes are very controversial in wind power, for example. In this country, you can't build onshore wind anymore. You can't do nuclear. Even offshore wind's getting difficult. People want to promote solar power, but that delivers almost nothing in terms of electricity. So, there's got to be a rational, sensible way forward on how to get the right kind of energy mix which can solve climate change.
Sure. I just think, in terms of fossil fuels being the kind of the best and worst thing that ever happened to us, and we've got us to the moon and back, but it's kind of like a drug that's very hard to get off, right, globally. And the difficulty is that fossil fuel companies, oil companies, their entire value is staked on future fossil fuels, and therefore to actually switch from that to alternatives financially is disastrous for them. So I think we've got a real problem with lock-in for fossil fuels, and I find it profoundly depressing actually.
Agreed, and it's not just oil. It's the gas companies. By the way, the gas industry gave 25 million to the Sierra Club, one of the leading environmental organisations in the US, just a few months ago, in order to help it campaign against coal and nuclear. So they're all attacking each other. Maybe that's the best we can hope for.
Right, over there, and perhaps we will make this the last one. You have the benefit, okay? And the lady next to you will make the last one, whoever she is.
It was interesting to see that amazing graph with the child mortality. One thing, I'm actually studying water management as part of my degree here, and apparently the main cause of child mortality is now not starvation, it's actually waterborne disease called diarrheal disease. It's actually overtaken starvation.
Yeah.
So when obviously you talk about GDP and the relationship between that and infant mortality, I think a key thing is obviously having the infrastructure in place to provide obviously drinking water and deal with wastewater so it doesn't contaminate it with cholera and other things that cause those things. I think therefore it's not the Western, you talk about Western consumption being a thing that's almost in tandem with improving health. I think it's the things like water and healthcare that are the key thing. And actually food, if I'm right, there's so much wastage of food that's already produced. We could take on a huge extra population, especially if, I'm not saying people should turn vegetarian, but there's been research showing that overconsumption of meat is not only causing the land use boundary to be pushed over, but just feeding the cattle and the amount of water that's used to, apparently just a kilo of meat takes 15,000 litres of water in its production if you count the lifetime and the crops that are fed for that. So yeah, I'm saying that we don't need, I disagree that we need Monsanto's technology, and I'm thinking of their track record. They were a big producer of PCBs. They produced Agent Orange. They've been crossing genes from fish with that in grain, and dabbling in saturated. And also the quote that you had from the Indian lady.
Crossing genes from fish with grain? Can you tell us a bit more about that?
That's a quote from one of my tutors who was talking to someone who was at a conference.
You didn't get that from Van Damme Shiva, did you? You didn't get that from Van Damme Shiva, did you?
No, I didn't. That's actually from a business management professor. But anyway, Monsanto, the quote which he gave, it was I think referring to the terminated crops that have been introduced into Indian agriculture on quite a wide scale, and the farmers had to go back.
No, that's another
Okay,
bit
give them a
ago.
chance now.
No.
Okay.
Well, terminated technology was never developed, so that didn't happen. No.
Okay, we'd like to hand to the lady next
But
to you.
I mean, I want to just your point on water is absolutely well made. I mean, there's been huge strides though in terms of providing access to improved water supplies in the last 10 years or so, and great progress made towards the Millennium Development Goals. So, and that's partly due to urbanisation because it's much easier to do that for people living together. I was in Colombia a couple of weeks ago, doing a similar talk to this at the University of Cali, and we go through all these awful like slum-type developments. You know, it looks like people are living really in an awful way. And the mayor of Cali, who came, said actually all of these houses have actually water connections. You know, and that's something that's happened just in the last few years. So things aren't always necessarily what we see.
Yeah. Okay. Sorry. Two quick things. One comment and one question. The comment is, I'm afraid I think you're wrong about the Biodiversity Convention, in that it doesn't have any binding protocols at all. What they agreed to in Nagoya was a set of rather vague targets, and those targets, even if they were achieved, don't come anywhere near the biodiversity boundaries. So I'm afraid that doesn't.
I didn't say it did. I completely agree with you.
Okay.
Yes, that's totally toothless, but there is a process.
Yeah. Well, except there's not even a protocol.
I think the smiley face was maybe...
Oh, no, I didn't mean it had been solved. Sorry. No, take off the smiley.
Okay. The second thing, which is a question, which is I think that there's another solution out there around food, which is if you really did have a kind of godlike agricultural management, there's a lot of evidence that if you grow the right things in the right places and you restore degraded land, you can actually, and you get your distribution sorted out, you can actually feed even 12 billion people without having to do lots more land use change. What that requires is an extraordinary amount of international cooperation. You have to trust other countries to be your producers of food.
What has happened specifically?
So what you do, if you look at...
could you just hold a bit closer?
Sorry. If you look at where the most productive landscapes in the world are, actually most of the most productive areas are the temperate regions where there's lots of degraded soil. We should be restoring those, not digging up tropical soil, which aren't very good anyway. And if you also optimise what crops you grow in each of those places, so you optimise the crop for the conditions, and then you get rid of the waste thing, you can massively increase agriculture. There's a recent paper about this which I can point you to. But it is really interesting that the big obstacle to that is actually a political one, because it requires countries to be willing to forego control over their own food crops, and it requires whole continents actually to forego production in order to maintain water or maintain biodiversity or whatever. And I was just interested in what your views on global governance at that level are, where countries have to trust each other sufficiently that natural resources get shared equitably.
I don't think it's about sharing natural resources equitably. That's a whole different thing, right? And is arguable on a lot of different levels. So that would take another 2 hours. But I think it's about increasing productivity in those areas which are farms. And if it's the same paper that you're referring to, which is one I read not so long ago, and I think it was in Nature, it was about closing the productivity gap. In Africa, for example, you've got a lot of land being used, but it's so unproductive because there aren't the inputs, there aren't the high-yielding crops, that you get a 10th or a 20th or even less out than you do in for the same amount of land used in the United States or in China or in India. So how do you close that gap? How do you use the land that we've got now? And that, of course, addresses poverty, because these are people who are working on the land, and if they had a lot more to sell, then they would be able to lift themselves out of poverty and improve their income. So there's a whole load of ways that you need to do that, but they are essentially about addressing poverty. I mean, and that, no one has a silver bullet to how you do that. So yeah, I don't really have much to offer other than saying yes, great.
Well, no, but don't you think that's another kind of solution, is doing the right things in the right places? Actually, I don't think it is just solving the productivity gap. I think it's more recognising that the Earth is a very heterogeneous place. You can do some things in some places a lot more efficiently until you can optimise the Earth system, if you like, by doing the right things in the right way.
In fact, no, yeah. I mean, one of the ways you can do that is by growing water-consumptive crops in areas where they have high rainfall. And there's this whole idea of virtual water, embedded water, if you like, actually eating local doesn't make any sense if you're going to be concerned about some of these things. So the international food trade networks save several, I think it's a couple of hundred cubic kilometres of water off that water boundary every single year by dint of that kind of specialisation. So it makes a lot of sense.
Okay, I think we should draw proceedings to a close now. I haven't got a microphone, but I'm sure you can hear me. So, Mark, that was a fantastic talk. Many of us who teach in universities could learn from how you demonstrate things and how you give your talk. And the content was extremely challenging, and I think the audience has taken the challenge, and we can all thank you for that. And at the end, perhaps in terms of this governance, gods aren't very good at collaborating with one another. So maybe the species, if it's a god species, has a problem. But anyway, thank you very much.